Hello and welcome guys to my YouTube channel. In this video, we'll be taking a look at word problems involving HCF and LCM. So let's start with this example over here. Buses leave the central station to Maplewood every 8 minutes and to Oak Ridge every 14 minutes. A bus to Maplewood and a bus to Oak Ridge both leave central station at 6 a.m. At what time will a bus to Maplewood and a bus to Oak Ridge next leave the central station at the same time? Okay, so it's important to understand the scenario here. So we have a bus to Maplewood and a bus to Oak Ridge. So the bus to Maplewood leaves every 8 minutes, and we know that they both left. They both left firstly at 6 a.m. All right, so it's a common time they left. So when is the next Maplewood bus going to leave? It's in the next after 8 minutes, so 6:08. And the next one again after 8 minutes, so 6:16. All right. As for Oak Ridge, the next bus will leave after 14 minutes, so at 6:14. And the next one will leave after 14 minutes as well, so 6:28. So as you can see here, what we're being asked is when will the buses leave at the same time? Now, as you can see, they will leave at the same time when you have a common multiple between the 8 and the 14. Eventually, they'll reach a certain number that's the same multiple. So what we need to do is to find the lowest common multiple for 8 and 14. So we'll go ahead and prime factorize the 8, 2, 2, 2, and 2. Sorry. There's a 4 here, there's a 2 here, eventually a 1. So 8 is equal to 2 to the power of 3. And the 14, we've got 2 gives us 7, 7 gives us 1. So 2 times 7. So as you remember, the LCM, we select all the numbers, so 2 and 7, and the highest power of each, so 2 to the power 3 and 7. So my LCM is 2 to the power of 3 times 7, all right, which would be 8 times 7, which is 56, all right? So as you can see, so when is the next time? It will be at 6:56 a.m., all right? So hopefully this makes sense because, again, if you keep going with these multiples, eventually you're going to hit 6:56 for Maplewood, and again also 6:56 for Oak Ridge, which is the lowest common multiple between the numbers, the minutes. Okay, let's move on to the next example. Ben goes cycling every 4 days. He visits the library every Monday. On Monday, 1st of October, Ben both cycles and visits the library. What will be the next day on which he both cycles and visits the library? Okay, so again, let's try to imagine the scenario. So firstly, we know that on October 1st, he did both. So our scenario starts at October 1st, right? The scenario, he cycled, and he also went to the library. Now, we know that he goes cycling every 4 days. So we can say that the next time he's going to cycle is going to be October 5th. We added 4 days, right? Now, as for the library, he visits it every Monday. And over here, 1st of October is Monday. So what will be the next Monday? It will be after 7 days. So what will be the date? 7 plus 1, which is October 8th, right? So then the next time for this will be another 4, so October 9th. The next time for a library will be another 7 plus the 8, which is October 15th. In any case, we want to find when will he go and do both. All right, what day? So again, we're looking for the lowest common multiple between the interval of every 4 days and every 7 days. All right, so for 4 and 7. So I'm gonna go ahead and factorize the 4 real quick over here. So 4 is equal to 2 power of 2, and the 7 is just 7 because it's a prime number. So the LCM, we select all the numbers, so 2 and 7, and then the highest power for each, so 2 to the power of 2 and 7. And so the LCM is equal to 2 to the power of 2 times 7, which is 4 times 7, so 28. So after 28 days, he will do both cycling and visit the library. Of course, the question is asking about the next date, okay? The next date will be October 29th, all right? Because we have 28 days over here, and we start October 1st, so after 28 days we will add 28 plus October 1st. All right, here's 2 exercises. You should attempt to do them. Pause the video, do them on your own, and then check your answer. Let's start with the first one. Ferries to Green Island leave a port every 15 minutes. Ferries to Blue Island leave the same port every 25 minutes. A ferry to Green Island and a ferry to Blue Island both leave at 10 a.m. When will a ferry to Green Island and a ferry to Blue Island next leave the port at the same time? All right, so you've got Green Island, I'm just going to call it Green, and Blue Island, Blue. And the first time that they left together was at 10 a.m. Right. Now, the Green Ferry leaves the ferry to the Green Island leaves the port every 15 minutes. So the next time is going to be 10:15. As for the Blue, it leaves every 25 minutes. So plus 25, so 10, 25. So as you can see here, we're going to need to find the lowest common multiple between 15 and 25. So we'll go ahead and prime factorize each of those. 3, 5, and 5, we get a 1. Over here we get 5, 5, 5, 1. So 15 is equal to 3 times 5, and 25 is equal to 5 to the power of 2. So the LCM, I'm going to select all the numbers, so 3 and 5, and I'm going to select the the highest power for each number, so 3 and 5 to the power of 2. So the LCM is going to be 3 times 5 to the power of 2. This is 25 times 3, 75. So after 75 minutes, so what will be the time? Well, we know that first they left at 10 a.m. The next time will be after 75 minutes. Of course, we need to understand that this is minutes, that we need to make this into hours and minutes. So 75 minutes is 1 hour and 15 minutes, right? Because you have 60 minutes in an hour, all right? So now I can go ahead and write the final time, which will be 11:15 a.m. All right, so I just added 1 hour 15 minutes to the 10 a.m. that I had originally. All right, let's take a look here. Jake is making hot dogs for a school event. He buys some packs of hot dog buns and some packs of sausages. There are 8 buns in each pack. There are 10 sausages in each pack. Now, Jake buys exactly the same number of buns and sausages. How many packs of buns and how many packs of sausages does he buy? All right, so you have the buns and the sausages. Now, if you buy one pack of each of the buns and the sausages, you're going to have 8 buns and 10 sausages, all right? But this means that the number is not really equal. You're going to have extra sausages with no buns to put them into. Now, if you buy 2 packs, you get 16 and 20, right? If you buy 3 packs, you're going to have 24 buns and 30 sausages and so on, right? So what you're aiming for is, when will I have the same number of buns and the same number of sausages? So as you can see here, every time we add 8, so these are multiples of 8, and this over here we add 10s, these are multiples of 10. So we're looking for the lowest common multiple between the 8 and the 10, a number over here that will be the exact same, right? So I'm gonna go ahead and prime factorize the 8. We get 2, 4, 2, 2, and 2, 1. And we'll write it right here. So 8 is equal to 2 to the power 3. As for the 10, we get 2, 5, 5, and 1. So 10 is equal to 2 times 5. So the lowest common multiple, I will just directly write it as 2 to the power 3 times 5, which is 40. All right, so the number we're looking for over here is 40. So when you have 40 buns, you'll also have 40 sausages. Now the question is asking how many packs of buns and how many packs of sausages does he buy? Well, I have 40 buns and 40 sausages. So for the buns, the packs of buns gonna be 40 divided by 8, because each pack contains 8 buns, and we get 5 packs of buns. All right, this is the answer right here. Now for the sausages, each pack contains 10. So dividing this by 10, we get 4 packs of sausages. All right, so that's it. This is the answer right here, and it makes sense. If you get 4 packs of sausages, you will have 40, and 5 packs of buns, you will have 40 buns. All right, so part B, kind of running out of space over here. Now, Jake wants to use 1 bun and 1 sausage for each hot dog. He wants to use all the buns and all the sausages. How many hot dogs can Jake make? Now, this is fairly easy. It's just a direct answer, which is 40 hot dogs. It's quite intuitive. I mean, you have 40 buns and 40 sausages, so you're gonna make 40 hot dogs. Because each 1 bun will go into each 1 sausage. So that is it. All right, so hopefully you get the idea behind these word problems, and thank you for watching.